What do the planets closest to us look like? Are there extraterrestrial life forms? These two questions have been preying on the brightest minds of the world for a long time. For centuries, people have come up with suppositions and theories, until in the 20th century, the scientific and technological progress enabled scientists to put into practice one of the most tremendous projects in space exploration. On the 5th of September 1977, the Voyager 1 probe was launched. 16 days previously, on the 20th of August 1977, its twin, Voyager 2, was launched. That was the beginning of a groundbreaking journey into the unexplored depths of the universe that has been going on for the past 42 years. During this long time span, the Voyagers have taken detailed photographs of Jupiter and Saturn, as well as their satellites. Uranus was closely studied, and its 11 moons were discovered thanks to the Voyager mission. It's the pictures taken by Voyager 2 that allowed scientists to be able to see one of the most controversial bodies in the solar system, Miranda, Uranus's satellite. The subject of big space travel was first broached in 1966. Gary Flandreau, still a student, published a scientific paper where he predicted the orbits of Jupiter, Saturn, Uranus and Neptune getting closer together by the late 1970s. The predictions proved to be accurate. On the 10th of March 1982, a full planetary parade took place. The 8 planets of the Solar System and Pluto were on the same side of the Sun at the angle of 95 degrees. The rendezvous of the giant planets provided opportunities for using gravitational maneuvering to fly the two apparatuses on the trajectories Jupiter, Saturn, Pluto and Jupiter, Uranus, Neptune. 10,000 possible trajectories were considered when the program was being worked out before the two of them were finally agreed upon. Apart from exploring furthermost objects of the solar system, the Voyagers have taken a great number of photos of our own planet, including one of the most well-known ones from a record distance of almost 6 billion kilometers. The idea of the picture, as well as its name, the pale blue dot, belongs to a prominent astrophysicist of the 20th century and an outstanding popularizer of science, Carl Sagan. The scientists didn't rule out the possibility of the Voyagers encountering extraterrestrial beings. That is why both spacecraft carried a gold-plated audio-visual disc with greetings in 55 different languages, significant scientific data, views of the Earth and its position in relation to its 14 pulses. Music holds a special place in the message to intelligent aliens. The collection of music includes classical works by Bach, Mozart, Beethoven, jazz pieces by Louis Armstrong and Chuck Berry, as well as folk music from around the world. The record also contains an instruction on how to access the data on its back. However, let us not dwell on the past, but look at the future of the Voyager project. Where are the spacecraft now, and what awaits these solitary space wanderers? The Voyager's chief mission, exploration of furthermost planets in the solar system, was completed long ago. Now, the main objective of both probes is studying transitive areas between the Sun and interstellar plasma. The Voyagers travel at 17.07 km per second and 15.64 km per second, respectively. At the moment this video is posted, the distance between the Earth and Voyager 1 is approximately 21.7 billion kilometers, while Voyager 2 is 17.9 billion kilometers away from us. The spacecraft's missions differ by their trajectory. Voyager 1 flew only by Jupiter and Saturn, while Voyager 2 went further and flew by Uranus and Neptune as well. That is the reason why Voyager 2 is never going to catch up with its twin brother. In 2012, Voyager 1 left the heliosphere boundaries to cross into interstellar space. It follows a hyperbolic trajectory, so Voyager 1 is not going to return to the Solar System due to the gravitational force of the latter. Its twin overcame the heliopause only in November 2018. Leaving the heliosphere does not actually mean leaving the Solar System. To do this, one has to go as far as the Oort cloud, a hypothetical region of the Solar System and a place of birth of ice comets. Only there will the gravity force of our star become negligibly feeble. The Voyagers are powered by plutonium-238 radioisotope thermoelectric generators. After 42 years, the power of the probes went down to 55% and is now 249 watt as opposed to 470 watt at the time of launch. This does not allow full application of the probe's scientific equipment. Only 5 out of 10 devices are operating now. The cosmic ray system, the low-energy charged particle instrument, the magnetometer, the plasma wave subsystem and the plasma instrument. Now the Voyager mission members are struggling to maintain the equipment's operation. According to preliminary estimates, the minimal energy generation required for scientific studies will be sustained till 2025. This time is hoped to be sufficient to explore interstellar space, in particular the structure of the heliopause. In the future, the data may be used in planning missions to the stellar system closest to us, Alpha Centauri. By about 2030, the probes will switch into a radio beacon mode and will transmit the last signal to the Earth in 2036. Thus, the life expectancy of the Voyagers will reach about 59 years. One must admit, it is quite a period for a space trip. In about 300 years, Voyager 2 is going to reach the inner edge of the Oort cloud and will completely leave it only in 30,000 years. According to the data provided by the Hubble telescope, it will take Voyager 2 approximately 2,000 years to cross the gas cloud in which the Solar System floats. It will take the probe about 90,000 years to get into other interstellar clouds. The remains of the Voyagers are presumed to reach stars as well. In about 40,000 years, Voyager 1 is supposed to pass Gliese 445, a star in Camellia Pardalis, within a 1.6 light-years distance. Meanwhile, its twin will approach Ross 248, a star in Andromeda, at 1.7 light-years distance. In 296,000 years, Voyager 2 will fly by Sirius at a 4.3 light-years distance. Life-sustaining planets are unlikely to exist in the vicinity of either Ross 248 or Gliese 445. Both of them are red dwarfs, each of them hardly half the mass of the Sun. Ross 248 is notable for being a flare star, that is, one that spontaneously flares up. At about the time Voyager 2 approaches Ross 248 closest, the closest star to the Sun will for a short time be Ross 248, and not Proxima Centauri. The Voyagers are to remain eternal wanderers in the universe. They won't be able to leave the Milky Way and are destined to wander around our galaxy. They have lived through scores of failures on their journey, but in spite of that, they continue to operate, transmitting important scientific data to the Earth. With the initially planned 5-year lifespan, they're pushing their 4th decade of service. As far as I'm concerned, the Voyager project is the most successful idea in the history of space exploration. The data received during the mission have changed man's perception of the Solar System. It is hard to tell whether an extraterrestrial race will ever read the message on the golden-plated discs on the Voyagers. Since the Solar System is 15 times faster than the Voyagers at circling around the galaxy center, it is possible that our planet will recapture the remains of the probes in some hundreds of millions of years, Maybe the message aimed at aliens will eventually be a greeting from a distant past to the human race of the future. Please leave your comments about what other impressive space exploration programs you would like to find out more about. Like the video if you enjoyed it, and don't forget to subscribe. Keep in touch!